I-35 crosses a multitude of bridges. One of them was Bridge 9340, where the western route through Minneapolis, I-35W, crosses the Mississippi River, the third busiest bridge in the state. Until August 1st, 2007. It's just after 6 p.m. Vehicles are at a standstill on I-35W. The cause is not rush hour traffic. The cause is a disaster. I-35W bridge has just collapsed. Over 450 feet of the main span dropped over 100 feet into the river. Then, a second section fell. In all, 1,000 feet of the deck truss collapsed. 111 vehicles fell with it. More than 50 fell into the Mississippi River. 13 people died, including one of the construction crew at work on the bridge deck. 17 workers survived the collapse. 145 were injured. So what went wrong? Bridges fall with alarming regularity. Sometimes the problem is on them. Sometimes the problem lies beneath. The Francis Scott Key Bridge in Baltimore was struck by a giant container ship. The Lee Sinshaw Bridge in China was struck by a barge. The Minneapolis incident was not the only bridge disaster in the U.S. in 2007. The MacArthur-Mays Bridge in Oakland, California, was annihilated after a fuel tanker crash on its roadbed. The inferno weakened the steel support beams. But the MacArthur collapse was not deadly. However, something else sets the I-35W apart: the amount of traffic. The bridges on the interstate system account for less than 10% of all bridges in the United States, but those bridges carry more than 45% of motor vehicle bridge traffic. I-35W carried 140,000 vehicles daily. For a bridge that opened in 1967, that's a lot of wear and tear. Investigators from America's National Transportation Safety Board examined the traffic moving on the bridge, but they discovered the problem was the stuff that wasn't moving. At the time of the collapse, the bridge's roadway was getting a new layer of concrete. The combined weight of the construction machines and material was nearly 290 tons. All that extra weight was an extra source of stress. But it wasn't just new concrete that concerned investigators. There was old concrete too. During 40 years of repairs and upgrades, the bridge's roadbed had gained 2 extra inches of concrete. Since 1967, the bridge's weight had increased approximately 20%. It seemed all this extra weight was to blame. But as investigators reassembled the broken bridge on the shore, they noticed damage that was not a direct result of the collapse. There was something troubling about the gusset plates. A gusset plate may not sound important, but it holds all the other pieces in place, like the corner bracket of a metal picture frame. A sheet of metal so strong, it tends to be an afterthought. At the time of the collapse, computer programs commonly used for load ratings on bridges did not include gusset plates in their calculations. I-35W bridge had been inspected many times since its construction. In fact, more frequently than required. But not its gusset plates. Inspectors suspected that extra weight was not the ultimate cause of the collapse. What if the cause was there the whole time? Investigators went back to the beginning. They discovered that the original design of the bridge was flawed. It turns out some of the original gusset plates were not robust enough for the load. These gusset plates were half an inch thick. They should have been 1 inch thick. They were bound to fail. The NTSB determined that some gusset plates on the bridge had bowed in 1999, 8 years before the disaster. But gusset plates did not merit a place in routine inspection. The board warned that bridge inspectors were not giving gusset plates the attention they deserve. Until that fateful day in August of 2007, when the gusset plate made its debut in the Failure Hall of Fame. As for the city of Minneapolis, the replacement bridge is made of concrete. There are no gusset plates. And when it opened in June of 2003, there was no cooler, sleeker edifice in Paris than the new Terminal 2E building at Charles de Gaulle Airport. Until May 23, 2004. Just before 7 a.m., the terminal was relatively quiet. At 6:52 a.m., witnesses reported cracking noises and concrete dust. About 5 minutes later, the ceiling collapsed. It was a huge part, nearly 100 feet long and 65 feet wide. If passengers had been arriving or departing, the scale of the disaster would have been horrifying. Still, 4 people were killed. Several others were injured. Workers tried to clear the rubble from the rest of the terminal building, but stopped work when more cracking sounds were heard. As authorities wondered if the whole structure was lost, engineers asked, "What went wrong?" Terminal 2E had been open less than a year. Buildings so new shouldn't just fail. Experts knew there were 2 probable causes: a failure in design, or a failure in construction, or both. Investigators looked at the steel. They looked at the concrete. Then they looked at the thermometer. The average minimum temperature in Paris in May is 50 degrees Fahrenheit. On May 23, 2004, the airport recorded an overnight low of -4 degrees Fahrenheit, 54 degrees lower than the average for that time of year. Buildings at that latitude are designed to handle a range of temperatures: warm on the inside, cold on the outside, or hot on the outside, cool on the inside. But Terminal 2E was not most buildings. Even its design was different. Inspired by advances in tunnel construction, the tubular terminal has no internal supports. A concrete shell wrapped around a steel frame. A building without internal supports relies entirely on its outer walls. So, if a wall fails, the roof fails too. Steel and concrete can expand and contract at a different rate. This is a process called differential thermal expansion. The failure occurred where a walkway joined the terminal building. The weakened inner concrete wall was not strong enough to counteract the punch force of the external supporting struts. Over the course of just 11 months, the push and pull of differential expansion and contraction had weakened the concrete walls. On that cold day in May, the concrete gave way. Expert analysis concluded the designers had not sufficiently considered the potential impact of differential thermal expansion. A French court found the Paris airport's operator guilty of involuntary manslaughter. Terminal 2E reopened in March of 2008 after 4 years of reconstruction, costing more than $170 million. This time, they skipped the concrete and relied entirely on steel.